Today we're solving multi-step equations. And in order to solve a multi-step equation, we want to use inverse operations to isolate our variable. Let's take a look at a two-step equation. Here it says the height in feet of a tree after x years is 1.5x plus 15. So in this case, x stands for the years. And we want to know after how many years will the tree be 24 feet tall? So 24 feet here is our answer. And we're working backwards to find the number of years, the value of x. So we want to isolate that variable. Normally, when we're doing problems, we follow the order of operations. Since we're working backwards, we're basically going to be doing our order of operations backwards. So normally the last step in order of operations is to do any addition or subtraction. That's what I'm going to look to get rid of first over here so that I can isolate my variable. Here I'm adding 15, so I'm going to get rid of that by subtracting 15. And I always need to make sure I do that to both sides. I need to keep a balanced equation. So adding and subtracting 15 cancel to 0, and here I'm left with 1.5x. On this side, 24 minus 15 leaves me with 9. So the next thing that I need to do is divide each side by 1.5. The opposite of multiplication, its inverse operation, is division. So 1.5 divided by 1.5 is 1, and 1x is really the same as just writing x. And 9 divided by 1.5 is 6. So the tree is going to be 6 years old when it finally reaches a height of 24 feet tall. Sometimes when you're solving an equation, you may notice that before you even begin to solve, you can combine like terms. Combining like terms creates an easier equation to solve. So in this case, I have 8x minus 6x minus 25 equals negative 35. Well, before I even start solving, I notice I have two x variables here. I can combine this. It's called combining my like terms. They both have a value of x. So if I have 8 x's, take 6 away, I'm left with 2x. Now I have a two-step equation to solve. Remember, the first thing I want to get rid of is any addition or subtraction when I'm isolating my variable. I have a subtract 25, so I will add 25 to cancel that out. And I'm left with 2x equals negative 10. Now I'll divide each side by 2, and I get x equals negative 5. In our next example, we see that the equation has parentheses, and the parentheses make it look like a very complicated equation. So the first thing I want to do is try to simplify a little bit. Let's get rid of those parentheses by using the distributive property. I'm going to distribute this 2 to everything inside the parentheses. So I'm going to end up with 2 minus 10x plus 4 equals negative 8. Now, just like in the last problem, I can combine some like terms. I have a 2 and a 4 here that can be combined. 2 and 4 can combine to give me 6. So I'll have negative 10x plus 6 equals negative 8. Now I have a two-step equation I can solve. I'll subtract 6 from each side to get rid of this plus 6. Gives me negative 10x equals negative 14. I will divide each side by negative 10. Here that cancels. And I know here that the negatives are going to cancel each other out when I divide. 14 divided by 10. Well, 10 goes into 14 once with 4 leftovers. So I could write x as 1 2/5. That's the reduced version. Or I could write it in decimal form. I could also have x equals 1.4. The reduced a mixed number here or 1.4 as a decimal are totally acceptable answers. I will take either. All right, for our last problem, we're going to look at a real-life application. So we want to use this table to find the number of miles you would need to run on Friday so that your mean number of miles run per day is 1.5. You want an average of 1.5. So first of all, let's try to set up a mean equation. So when we're finding the mean, we're adding up all of our pieces of data, 1 plus 0 plus 1.5 plus 0 plus whatever x is going to be. And since it's 5 days of running, we're dividing by 5, and we want a total of 1.5. That's what we want our mean to be. So the first thing I'm going to do is combine some things up here. You'll notice that 2 plus 0 plus 1.5 plus 0, these can all be added, and I get 3.5 plus x divided by 5 equals 1.5. Now, I can't get rid of this addition here because it's all part of my numerator. I want to get rid of this denominator first. This denominator can also be looked at as divide by 5, so I'm going to multiply by 5 to get rid of that. So I get 3.5 plus x equals 7.5. Now I will subtract out this 3.5 to get the x by itself, and I get x equals 4. So if I want my mean for the week to be 1.5 miles run on Friday, I got a lot of running to do. I need to run 4 miles.